Thanks very much for those who've stayed or who've come on. I was going to make a joke about thanking Anthony for leaving him the job of being the follow-up act to him, and it seems it's an appropriate joke because everyone left. So, hello. My name's Martin White. I've been a network and security consultant for around 15 years. And I would like to assure you that despite all of that time working in security, whilst I might be a little bit cynical at times, I'm not Voldemort or Mordak. So since about 2005, I've been working with the Centre for Internet Security. First, I was contributing to some of the Windows and the Cisco benchmark communities. And then later, I led the beta testing of the configuration analysis tool, or configuration assessment tool, which apparently I've been calling wrong for the last 10 years. Later on, I basically didn't shut up about the need for CIS to support a wider range of network vendors than just Cisco, as we did at the time, and kind of got the challenge thrown at me to, well, in that case, go and write some other benchmarks. So since then, I've been the benchmark author and editor for the Juniper benchmarks. So today, I'd like to talk to you a little bit about the problems that organizations are facing trying to implement and audit security controls that are both strong and consistent across their whole infrastructure, be that on-premises services, software services, or in the cloud. I'd like to introduce you to the Centre for Internet Security and specifically to the CIS Controls and the CIS Benchmarks projects, and I hope that they're going to be useful to you in trying to achieve that. One more thing before we do start. I'm not actually a member of Centre for Internet Security staff, and this is not an official CIS talk. Useful.com is my consulting company, and it's not an official vendor for CIS or anything like that. So I'm a member of the organisation, and obviously a big fan of the organisation because I give hundreds or thousands of hours of my work as a volunteer to lead one of the benchmark communities. But that being said, these are my own opinions. They, if you spot any, they're my errors as well. So just please be aware of that. So let's have a quick look at all security talks need the scary bit. So some of the challenges that we're facing as systems engineers, as network engineers, as IT professionals, we know that we need to harden our systems and our infrastructure. GDPR, PCI DSS, all of the myriad standards we're supposed to adhere to tell us we're supposed to harden everything. And I think if anyone is playing security talk bingo, then that's now a full house. More importantly, though, than ticking off lots of compliance boxes, we need to harden our systems because we know that there are attackers out there. All of these headlines tell us there are attackers out there, even if we don't bother to look in our own logs to see that fact. We know that we're a target, so it doesn't matter what kind of infrastructure you have, what kind of data you host. If you're not going to secure it, then someone will see some value in stealing it, in holding it for ransom, or in some other way exploiting your unprotected systems for their gain and your loss. And of course, not only are we a target, but we are abundantly aware that if we just connect things straight to the internet and don't harden them at all, they are very vulnerable to attack. There's something else that we know as well, and it's a little more uncomfortable. Let's look at that last headline about the TalkTalk attack where they lost 157,000 customers' details in 2016. TalkTalk's failure to implement the most basic cybersecurity measures allowed hackers to penetrate TalkTalk systems with ease. And this is a quote from the Information Commissioner in a report on that breach, and again, that lost 157,000 customers' details. And I'm not meaning to pick on TalkTalk here or drag up old news. We could equally talk about Equifax, or I've had to rewrite this bit several times in the last few weeks. Let's add Marriott in there. Their breach went on for 4 years before they realised they'd lost 500 million records. But this article came up whilst I was looking for articles to screenshot for the last slides, and it does illustrate that other point. Many, and possibly even most of the breaches, including those that are resulting in the loss of large volumes of our personal and confidential data, are the result of little or no basic security controls and standards having been applied to the targeted organisations. And so often many of us in IT are reading these headlines, but in our heads we're saying, there but for the grace of God go I. Okay, so if we all know these things, and if we are the IT professionals that all of us in this room claim that we are, why are so many breaches happening as a result of unprotected or unpatched systems? We might not have always helped ourselves in security. Quite often we've been a little too willing to play the role of MORDAC, preventer of information services, insisting that security has to trump all other concerns like usability or project schedules or profitability. In many organisations I work with, I go in and I hear management proudly proclaim security and compliance are our #1 priorities. But of course that's not true. If that was true, we would do exactly as MORDAC says, and we wouldn't deploy the services. Nice and secure then. But we do offer those services. We do it to make money, either by selling the service directly or some product, or by letting our staff do their jobs and further our organisation's aims. So, in fact, while they say that, often the direction from the pointy head boss, because I'm going to just stay in the realm of Dilbert for this whole talk, is that we have to make it work now, and then we can secure it later. Let's make money. And of course, often by the time secure it later comes along, the engineers that deployed it are now busy deploying the next make it work now priority. So secure it later is either piecemeal and is done in whatever time the engineer had left over, or it just doesn't really happen at all. Now, part of the problem here is that management often sees security as a roadblock to doing what they want to do, which is get that project out there, get that sexy new bit of code out there, start earning money. And as I say, that is partly our failure in security, because we have been MORDAC and we've been saying no instead of trying to help deliver it in a secure and a timely manner. We do need to roll those services out. We need to in order to pay the bills, and security that stands entirely in the way of that simply isn't going to happen. It's going to cut off the lifeblood that's paying for us to be there securing it in the first place. So I don't think it's ever going to be really true 100% to say that hardening systems is going to be seen by management as something that speeds up delivery in and of itself. But it can and should work in concert with and encourage practices like automation and good workflow management, which do speed things up as a result, even while security has to remain the focus of those of us in InfoSec. So we need to stop being a roadblock. We need to be, at worst, a speed bump and help to deliver that service. A speed bump's not so bad. After all, to err is human. To really screw things up, you need a computer to automate your mistake. So it's not bad if we do slow down just a tiny bit. But why is it that we're so often seen as that roadblock? Well, hardening systems is historically kind of difficult. It takes time and effort to harden the systems at deployment, and without the right tools and methodology and training, it's going to take too long and it won't happen. It takes even more time and effort to harden your systems retrospectively without breaking the service you push to roll out now, if you ever do get to secure it later. And it's going to take time and it's going to take effort to maintain that posture and to audit your systems. There's so many individual things that we have to check. So I had to look through the current CIS Windows Server benchmark whilst I was writing this, and there's over 300 individual basic level 1 recommendations for settings which you should check, you should audit, and you should change. Now that's everything from how you should configure your automatic updates to applying sensible crypto policies for remote desktop sessions. And if you don't have those tools and guidance and you're trying to do this manually, that's going to be a pretty tough ask. And it's not like we're just hardening one Windows server when we roll out a system. Your infrastructure, whether it's physical on-prem, whether it's a network, whether it's in the cloud, it relies on so many different layers. And so often, even within IT jobs, we're insulated and isolated from that. We don't see all of the layers we rely on. You might have some Cisco routers that run in your WAN and some Palo Alto firewalls on your internet connection and maybe some Juniper switches in your LAN. You might have some wireless access points, and to run that, you might have some Debian Linux servers, and maybe they're running Radius for 802.1x, they're running with your Windows domain controllers, so on and so forth. You've got your AWS Linux, you've got your Oracle, all of these different layers with different teams looking at them. The point is that any service has lots of components in it, and each of those components has hundreds of options, just like the Windows server, which impact on that security posture of the whole service. So we need to audit them against some baseline, both at the point where we deploy them and over time, so that we can catch changes in best practice as that changes, and in our config if that changes. And none of us can be that expert on all of those hundreds of choices for even one platform, never mind for all of the platforms that are under our care and that we're responsible for securing. So, after my scary bit, it was to try and better equip us with the tools and the knowledge that we need to set and configure those baselines and to audit them, and also to provide a level of measurability and accountability to management and to business leadership that organisations, including ISACA, that's the Internet, I'm going to read that one, the Information Systems Audit and Control Association, the SANS Institute, ISC Squared, the American Institute of Certified Public Accountants, and the Internal Auditors Association all came together in 2000 to form the Centre for Internet Security as an independent non-profit. And I think that the inclusion of those bean counters there, the accountants, the auditors, is interesting, and having them as a driving force trying to control this risk around security, because it shows the role that CIS is designed to play. It's not just there to provide us with the technical tools, but it's also there to link that with auditability and accountability to the business and to serve the needs of the business to roll that service out, not to serve Mordak's ego in saying no to everything or telling us we've got to look at the sun to log in. So, Centre for Internet Security is a member-driven, non-profit organisation. It's headquartered in New York in the US, but it offers free services to the whole internet community. And those include the CIS Controls, which are a prioritised set of actions and controls to help you start your cybersecurity hygiene programme. And we're going to look at those in a bit more detail. The CIS Benchmarks are a community-driven set of hardening standards that are widely accepted as best practice and are written by experts drawn from within the CIS membership community in conjunction with the wider membership. And before they get published, they go through a strict consensus process. And again, we'll look at some specifics of benchmarks in a moment. The configuration assessment tool is an automated tool to help you compare your configuration to what the benchmark suggests your configuration should be. And there's a free version, CISCAT Lite, and hopefully we'll have time to have a little bit of a look at that, but that's relatively limited. It gives you a few platforms as a prioritised approach. CIS RAM is a risk assessment methodology. So it links in, it uses the CIS controls and benchmarks, or optionally does, and it includes templates and methods and examples to take you through from a beginner level through to an expert level to conduct an effective cyber risk assessment for your organisation. And MS ISAC advisories are 3 threat and vulnerability feeds from the Multi-State Information Sharing and Analysis Centre. Now, that's a 24/7 security operations centre that CIS runs for US state and local government agencies, but the threat feeds and information from there are available to everyone. As I said, they run some extra services for US government agencies, from states, elections, infrastructure, and so on. But we're in Bristol, Southwest England, not Bristol, Georgia, not Bristol County, Massachusetts, so I'm going to skip that. So there's a few extra paid services that are available, and the first of these is Hardened Images. So this is pay-as-you-use Windows and Linux VMs or containers, and these are pre-configured to either level 1 or level 2 benchmark standards, and we'll look at what I mean by that in a moment. You can deploy them on AWS, on Azure, on Google Cloud Platform, through their marketplaces, just as you would any other VM or container. And the idea is to give you a head start in securing your cloud environment to a known set of standards, rather than roll out a VM with lots of automation and then manually remediate it to harden it. They're available to both CIS members and non-members. So, speaking of members, you can also become a Secure Suite member as an organisation. And that's going to give you additional tools for automation and reporting against the benchmarks. You could be an end-user organisation, which includes things like the UK government and Amnesty International, lots of American universities and US government organisations like NASA or the US Army, and hundreds of other companies and organisations. You can also, if you're a vendor of a security product, or you offer managed services, or you are a consultant, you can join under membership classes which let you make use of the CIS tools and resources commercially as part of your product or as part of your consultancy. In any case, being a CIS Secure Suite member is going to provide you some extra tools, and these include a pro version of the configuration assessment tool. That's a more powerful version, and it, I believe, currently implements about 85 of the benchmarks that you can automatically assess against. It can also be automated and can report into a dashboard that you install in your environment to correlate that and track automatically over time. You can also, as a member, create your own internal security standards derived from the CIS benchmarks, but customized to what you need to do. So for instance, if you have Juniper routers, I'm going to base it on Juniper because that's my benchmark. So if you've got some Juniper routers in your organization and you know you only run OSPF and you only run IPv4, then you might want to go through the main Juniper benchmark and turn off all of the things that relate to BGP or MPLS or IPv6 and so on. So you're not having to wade through lots of reports about not securing services that you're not going to use. You can then export those as OVAL or as XML or as Word documents to both help you document and audit with CISCAT Pro and to automate your deployment of the benchmark. Talking of automation, if you remember, you also get access to various automated remediation tools. So this is things like group policy objects, which will automatically apply CIS hardening to your Windows estate and manage through your Active Directory. Or for Linux, then there's configuration scripts, I believe also for Mac OS now as well. Okay, so there's going to be a couple of nags, depending how well I do on time. So this is the first one, nag number 1. So I said as a member of CIS, one of the things you also benefit from is you get to participate in that community. You can contribute directly to the CIS controls and the CIS benchmarks. You can raise questions and tickets, so if there's something you think isn't right or you want to know the logic behind it, you can raise a ticket to one of the authors or the communities and we'll answer that. Now, that sounds good, but maybe your organisation that you work for isn't a member. You can still join as an individual, which is what I did originally, and you can still participate in those community-driven efforts. You just won't necessarily get access to all of the tools, certainly not for commercial use. If you hold a CISSP or a GIAC certification, you can also earn continuous professional education credits. So if that sounds like something you want to do, then you can come and speak to me after the talk, or you can go to workbench.cisecurity.org and you can join. So nag over, let's have a look at one of those projects. So CIS Controls are a set of 20 prioritized actions to help protect your organization. Pardon me. Let's try that again. So it's 20 actions that are prioritized, and they're there to help protect you against common and critical security vulnerabilities. Now, 20 actions that are quite high level and abstract might sound rather limited, but those 20 controls are designed to provide a measurable defense in-depth set of standards, and they're developed just like all CIS standards collaboratively by the cybersecurity and the intelligence communities, and they're there to help you gain a basic cybersecurity hygiene. So they were originally created in 2008 in response to numerous attacks on critical infrastructure in the US. They're now on version 7, and you might know them by other names. You might know them as the SANS critical controls. Obviously, CIS and SANS work very closely together. They're recommended by a wide range of organisations, including the American National Institute for Standards and Technology and the UK Centre for the Protection of National Infrastructure, who both recommend using the CIS controls as a starting point for your cybersecurity process. Those 20 controls have been drawn slightly weirdly on there. Those 20 controls are prioritised. They're there to take you along your security journey. I'm going to use one more cheesy security quote in this, which is that security is a journey, not a destination. We can loop round, which is why we're showing it as a circle, but each builds on the last. So they're divided into 3 groups. The first 6 controls cover basic, but the most critical steps. So things like Control 1, which says inventory and control of hardware assets. Obviously, if you're trying to secure an infrastructure and you don't know what computing and data resources you have, you're not going to stand much of a chance of securing them adequately. Another example of a basic control is that you should control the use of administrative privileges. And again, I'm hoping it's not going to be a big surprise to anyone in this room or this conference that if all of your users are logging in as root or as administrator all the time, it's probably not good. So for the most part, the basic controls are relatively simple steps like that. They're cheap or free to achieve, but they're going to, if you've not implemented them, have the biggest impact on your cyber hygiene. And they're most important steps for any organisation and potentially any individual to take. The fundamental controls sit on top of the basics, and they're there to continue to create a secure base to build your environment and your infrastructure. So this is things like Control 11, which says we should secure the configuration of our network devices. Now, this builds upon an earlier basic control, which said we need to secure the configuration of our endpoint systems. Now, both clearly are critical and important, but possibly that basic control of your endpoint systems is even more important because it's where the data is typically decrypted, it's where your data and your users both exist. So we get you to secure the end systems and then later on secure the network that they run over. In both cases, the relevant CIS benchmarks are a tool you can use, you don't have to use, to help you achieve that. Control 12 suggests that we should deploy boundary defenses. So this is making use of firewalls, intrusion detection, intrusion prevention, unified threat management solutions. Another sub-recommendation there is that we should ensure two-factor authentication is used for all of our remote access sessions. So foundational controls are potentially a bit more complex, a little more expensive to achieve than those basic controls. You could say they give you a little bit less bang for your buck. But as the name suggests, they're fundamental to laying that groundwork to secure your organisation. So we've left with 4 controls left, and these are the organisational controls. And as the name suggests, they focus on the processes and the systems for good management of your cybersecurity and for maintaining the ongoing use of the other controls. So organisational controls can be things like Control 17, which suggests we should implement a security awareness and training programme for our staff, or the final control, 20, the last one we should implement, which says we should do regular pen tests and red team exercises. All the way through, each control builds on all of the ones that came before, and they are prioritised. So if you've not implemented some of the basic controls in your organisation, that should be your priority before spending time and money and resources achieving some of the foundational controls, which should then be your priority before moving on to the organisational controls. So you can do pen tests and red team exercises before you've achieved the basic controls if you like, but effectively what you're going to do is you're going to get a very expensive report that tells you what you already know, which is that you should do some basic cyber hygiene. So you're going to get much better value for money implementing Control 20 after you've done all the other 19. So I'm not going to rabbit on too much more about the controls because there's really good videos on the CIS YouTube channel that break down all of the controls and explain what the aim is. So I'm going to move on to CIS Benchmarks. And they're really the core part of what I want to cover here, but understanding them within that framework of the controls. They've been a big part of my involvement with CIS over the years, and I think are still one of the key services that CIS provides. You can download them for free from the URL there, and that's for both members and non-members. You can download it as a PDF guide. If you're a Secure Suite member, you can customize it and you can download it in other formats like Oval and XML to help you automate from it. But whatever form you get it in, they represent best practice guidance that's widely accepted by the security community, and they cover over 150 technologies or services now. So each benchmark is platform, role, and sometimes service specific. So for example, with the Windows benchmarks, we've got separate guidance for Windows clients and Windows servers, and then additional benchmarks that are going to give you coverage for common services like SharePoint or IIS or Exchange. Similarly, in the Linux world, we've got various OS benchmarks. So there's one for Amazon Linux, one for Debian, one for Ubuntu, Red Hat, and there's also a distribution independent benchmark which you can use. And then common services like OpenSSH, MongoDB, Oracle, Bind, etc. Each is covered in its own separate benchmark. So no matter what platform it is that you're implementing, the idea is that a benchmark is going to give you in-depth, specific technical guidance. So it's going to both give you details of what settings are we suggesting you check and what are we saying you should set them to, and also some brief explanation as to why we are saying that. So that makes them quite in-depth and quite lengthy guidance. For example, the current Apache Tomcat benchmark for just one service is over 90 pages, and the current Windows Server benchmark is over 900 pages of settings. That information, it's a little bit repetitive because we divide it up into individual atomic recommendations. Now, I say atomic because the idea here is that each recommendation stands entirely alone. You can improve that specific bit of your posture by setting that one thing. And so it's going to have some repetition of the explanation of what we're doing. An example of this is in the JUNOS benchmarks, we split up the benchmark in the same order as the configuration, which is very hierarchical in Juniper. And hopefully that makes it easier to find recommendations. Under the SSH section, we have 12 recommendations at the moment, and each one affects just one aspect of your SSH configuration. So that might be one that says use version 2 and why you shouldn't use version 1. Another one which outlines and explains what ciphers are acceptable, and another one that covers what MACs or key exchange and so on. So in addition, each recommendation is going to be classified as part of one of those level 1 or level 2 profiles that we mentioned before. And we're also going to class it as being either scoreable or non-scoreable. So a scoreable benchmark is something that's measurable, and that if you did a CISCAT analysis, it's going to give you a pass or fail. Whereas a non-scoreable item might be some more general advice or some very use case specific advice that we can't really test in that yes or no, pass or fail kind of way. So, as I said, it's divided into level 1 and level 2. A level 1 represents the base set of recommendations for your chosen platform. The aim is to reduce the attack surface. It's not about perfection. It's turning off things that are insecure out of the box. So turning off unused or insecure services. For instance, we tend to suggest you should probably consider using SCP and not FTP, particularly for sensitive files like configuration backups. The aim is to have minimal disruption on the normal service that that system gives you, and also require minimal, but sometimes still some, changes on other neighbouring systems for that to work. The idea is applying a level 1 shouldn't hinder your business as usual operations. They represent what that benchmark community considers to be the minimum level of compliance and change from the default state that is required to improve the posture of that target system. Now, I did say we do a lot of testing, and we aim to have no impact with a level 1, but we give notes and we give impact assessments or impact statements along with each recommendation. We would suggest that you read them and that you do test before deploying to your live £1 million system. So let's have a look at what a level 1 benchmark looks like. Because I've been writing updates on them this week, I'm going to use those SSH recommendations for the new JUNOS benchmark. Please note, though, that these are drafts. They haven't gone through consensus yet, so please don't apply this advice and think that it's compliant with the benchmark. So each recommendation has a reference number. This is 6.10.1.6. Now, is just because we have quite a few subsections because I arranged the JUNOS benchmark hierarchically to match the configuration. So this is just the 6th recommendation under the Edit Systems Services SSH hierarchy. Each recommendation then gets a straightforward title, and these follow the same basic format. So in this case, we aim to ensure that strong ciphers are set for SSH. We're going to give each recommendation a scoring status. In this case, it is scored, which means if you assess against it with CISCAT or another tool, it's going to give you a pass or fail. This isn't one that's open to any kind of interpretation. And we're going to give it a profile. In this case, this applies to level 1 profiles and not level 2. So again, this means we've done a lot of testing and we consider this to be the minimum level you should achieve. And in this case, I've done a lot of testing with different Juniper platforms, different versions of software, loads of different SSH clients and versions, and so on. So next, we're going to add a high-level description, which might appear in some of your automated reports. And we're also going to give you a more detailed rationale statement. So here, we're going to explain what SSH is a little bit and why it supports a huge range of possibly not so good ciphers, and the fact that a lot of those ciphers we consider to not be suitable for managing a sensitive system anymore. In this case, the current recommendation is that we should restrict at level 1 to you using just triple DES or AES-based ciphers only. We're then going to give you an audit procedure. This is a set of commands you can issue from the command line of any JUNOS device that will tell you yes, you're compliant, or no, you're not. There's actually two commands that would be used here, but I've cut the second one off so it's reasonably legible. And all we're doing is we're just interrogating it and saying, is there anything set here that is something other than AES or triple DES? We're then going to give a remediation action. So if you do our audit and find, no, I've got RC4 set, how do I remove it? So in this case, first we tell you how to remove just one cipher, like RC4. Or if you've got a whole list of ciphers that are not so good, we tell you how to delete all of them, and then how to set a list that are compliant. In this instance, we've included the Galois counter mode of AES, which isn't supported universally on Junos, so we go on and give some additional options for how to support this level 1 recommendation on all currently supported platforms. As I said, in most cases, a recommendation is also going to include an impact statement, which is going to warn you of any potential impact on your other systems that we've seen by applying this. In this case, if you've got old SSH clients, you might cut yourself off because they don't support the right ciphers. And again, we have some notes, which again, in this case, are just going to expand on the fact that AES in GCM isn't universally supported at the moment. Sometimes in the notes, we'll have some minor impacts as well. So on one of the related standards for setting the acceptable authentication codes, we warn that versions of PuTTY below 0.7 won't work once you set the authentication code to SHA-2. We don't consider that worthy of being a full impact statement because you shouldn't be running PuTTY at less than 0.7 at this point. We shouldn't be running old PuTTY clients to manage our environment. Finally, we're going to give some default values as it applies to most or all current platforms. We're going to map the recommendation to one or more of the CIS controls that we looked at earlier and the specific recommendations within that framework. And we're going to give some references to external standards and technical documentation. This is a draft, and I haven't gone through and updated to the current version of PCI DSS yet. But I left that in there because one of the places that people commonly come to the benchmarks is when they're doing PCI DSS, which lists CIS benchmarks as one of your acceptable hardening standards. Okay, so if level 1 recommendations are about setting that baseline, what do we have level 2 for? Well, level 2 are there for achieving defense in depth. They're for environments where security is your paramount or your primary overriding concern. And because of that, they might impact usability of basic functions. They might require additional licenses that aren't there as standard or only work on very specific versions. And they may have a significant impact on compatibility or interoperability. So as an example, there's a level 2 change in OSPF for authentication in the new Junos benchmark. And if you apply that, there are some Cisco routers you're just not going to be able to work with anymore because they don't support that extension. So you want to be a little more cautious testing and applying these. So as I said, we tell you should read the impact statements and the notes and tests for level 1. At level 2, we really, really mean it. Those interactions might not just be how it behaves on that box and that config, it might be how it interacts with something at the other side of your network or your environment. And we haven't been able to test that extensively to do every possible version. And they might be subtle, but a level 2 will almost always have an impact if you don't mitigate it. So we'll have a look at a level 2 benchmark, which is setting a higher level for that same set of ciphers that are acceptable. In this case, we've changed the title to ensure only Suite B ciphers are used, and we've set the level to 2. Again, we're going to give you a description and a rationale statement. And the beginning of the rationale statement repeats what we said about SSH before, so I've cut that off. But we go on here to explain that we've been influenced by the NSA's Suite B standards, and that those are set in RFC 6239, and that they state that we should only use AES with 128 or 256 bit sizes in Galois counter mode. because we're checking the same basic thing, but for a different setting, the audit is pretty much exactly the same as the last one we saw. It's just the result will be a bit stricter. And again, the remediation is going to be very similar. So we're going to tell you how to delete your unsuitable ciphers and how to set just the list of ciphers that we're interested in. Now, you'll notice that that's using the OpenSSH standards, and that's because Junos, like an awful lot of embedded devices, uses OpenSSH under the hood. And because of that, we've worked collaboratively with the specialist OpenSSH team, who include people from OpenSSH and various agencies with 3 letters. And we've collaborated and been steered by them in choosing our ciphers for this. So again, we're going to have an impact statement. We're going to have some notes. Here, the impact statement will be a little bit stronger. It's going to warn you that if your management systems aren't Suite B compliant, this is probably not going to work. We also warn you in the notes that the OpenSSH version that's used on Junos can't be made fully Suite B compliant, and that's because Suite B requires that we do our authentication exclusively using X509 certificates, and Junos doesn't support that at the moment. The one other thing that's of interest there is, again, I said before that some Junos devices don't support AES in Galois counter mode, which means some devices can't implement this level 2 recommendation. So if you're an organization where security is that paramount that you should be deploying level 2, this might mean that it's serious enough you need to throw that device away and replace it with one that does support it. Beyond that, a level 2 recommendation has the same things as a level 1. So we're going to give you information about the default state, the CIS controls that it maps to, and some external references like the RFC or the relevant PCI DSS recommendations. Okay, so I hope that's given a bit of a better overview or a bit of an introduction as to what the CIS controls and benchmark projects are about, and that will be useful to some of you. Now, we don't expect that you're going to use the 900-page Windows Server benchmark as bedtime reading. I've had to read through the 200-page Junos benchmark to check it before, and it's not great. It's quite repetitive. And the reason it's repetitive is that we need them to stand on their own. A lot of people are only ever going to use them either through the pre-hardened images or the automated remediation tools, or through external audit tools like Tripwire or Qualys or Chef for some recommendations, or CISCAT. And I'm just looking at Chris to see how I'm doing for time. Marvellous. We can get 4 more slides in that. So, CISCAT, and we're going to have a look at the free light version, which you can download, as I say, for free from the CIS website. That currently will do scans for Windows 10 clients, Google Chrome, Ubuntu, and macOS benchmarks. And you can use it as much as you like on as many systems as you like. The aim is we're focusing on that basic control about hardening your endpoint systems with the free tool. So for CISCAT, it runs in a GUI interface. With the Pro version, we also add a CLI to give you better ability to automate your reports. But in both cases, it uses a Java runtime environment, and both the JRE and the CISCAT tool can be run from a removable drive, or in the case of the Pro version, can be run over the network. With both, you're going to choose what scan you'd like to do and at what level, and it's going to spit out a report. It's going to give you a pass or fail and an overall score as a percentage, and then it will break down all of the settings and tell you whether you passed or failed within those sections. If you click through on an audit failure, then it's going to pull up that information from the benchmark. And as I say, this is why they need to be atomic, because often you're only going to encounter this one recommendation in isolation on a report. So in this case, it's found that Xbox accessories are enabled, but we think probably on a corporate machine you shouldn't have Xbox accessories enabled. And it's telling you a bit of background on it. How do we fix this? What's the impact? Obviously, if you turn it off, the Xbox functionality is not going to work. How we tested it, and it will go on and give you some more information about extra reading you can go and look up as to whether you think this is a good idea. As I said, with the Pro version, not only can we automate it over the network or use a CLI to drive it, it also adds support for over 65 platforms. And I know that's growing because the guys that develop it are constantly asking me for Junos configs that they can use to develop that. So they are growing the family of supported platforms. It also adds a centralized dashboard. So this is a service you can run in your infrastructure or in the cloud, which will go off and automate running your reports across your infrastructure and keep your reports over time, let you drill down. You can separate it out by average scores or by specific systems or particular tags. So you might have your PCI DSS environment and your less secure environment and so on. Okay, so just before we go to a Q&A, I'm just going to do a second nag. So as I said, CIS provides a lot of free services to the internet, as well as some paid membership services. There is a permanent staff, it's about 160, but an awful lot of those guys are working 24/7 shifts in the Security Operations Center, which are part of the offerings and are funded by the US government agencies. Some of them also work in development roles or in working with vendor members to certify tools like Tripwire or Qualys. So like a lot of other kind of open source and good of the internet type organizations, a lot of those core components, the CIS controls, the benchmarks, are developed by the community and developed by volunteers. So it looks good on your CV. You get to come and do interesting talks and bore rooms full of people or semi-full of people. And you can earn CPE credits doing it. And it is really rewarding. So if you are interested in that, like I say, you can go to workbench.cisecurity.org and sign up, or come and speak to me after the talk. Does anyone have any questions? Or does everyone want a coffee?
We've got a couple of minutes. Then we've got a 25-minute break. So does anybody want to ask? Maybe we've got time for 2 questions. 2 hands went up.
Oh.
So when it comes to internet security, I'm a little bit skeptical because unless you get the security level up really high, is there actually any point in putting a flimsy lock on your front door? Do you see what I mean? Because there was a time when actually you got rid of a lot of the risk by making it reasonably difficult for people, because most of the people who came knocking on your door didn't have sufficient skills. But these days we see a few people hack systems in order to sell the information.
Yeah, so I mean, security is always going to be a compromise between the cost of implementing a thing. So we saw there was a level 2 recommendation where some perfectly valid kit can't support it. So if you were trying to achieve level 2, you'd have to throw away a bunch of firewalls and buy new ones just to support an additional cipher. So it's always going to be a cost-benefit analysis and also an impact-benefit analysis. Like I said at the beginning, if we wanted to be really super secure, we'd bury it in concrete and station the SAS on top of it. But it would be a rubbish service, and no one would be coming here and doing talks about how they made their service agile by burying it in concrete. So there's a little bit of that, and that's why we provide the 2 levels. The level 1 recommendation is still narrowing down as much as we can without giving you massive impact, and it's fiercely debated. So triple DES, for instance, is still included in the FIPS 140-2 standards, which a lot of crypto modules have to meet, and in common criteria. But there's a lot of debate, and this is why I highlighted it's a draft, as to whether we should still include triple DES, because very highly funded actors can now repeatedly break it. And so there are some additional notes there about that. And we may, by the time it comes to publication, have dropped triple DES from the support and only allowed AES. But if we disallowed AES in Cypherbox training or in CTR mode and only allowed GCM, then the support impact would be disproportionate to the additional security impact. So
I absolutely follow everything you've said, but to be honest, I'm not quite sure it actually addresses the question, which is if you can't do it properly and thoroughly, is it worth even doing anything at all?
I mean, I would say that the work factor in breaking a VPN or an SSH session that's encrypted with RC4 or Blowfish versus triple DES even, or certainly AES CBC, is a massively, it's an order of magnitude or several orders of magnitude. So we are taking it from any guy with a laptop can hack me to any minor state actor can hack me. So it's a big improvement. But if you are, coming from GCHQ or something, then maybe you want to go to the level 2 or maybe a little bit further than that. So it's always a balance of how much can I spend versus who are the opponents who I'm trying to defeat. I totally take your point, but in an ideal world, but if we do that, then we just become more that going, well, in an ideal world, you'd have to look at the sun to log in, and it's not going to happen for most people.
I mean, I don't want to hog it, so I'll hand over, but focusing on whether it's easier to hack this encryption or that encryption is a little bit artificial, because actually they're going to come in a completely different route anyway.
And that's why there's, several hundred pages of recommendations. We were just looking at ciphers on SSH in this instance. So we're looking at addressing those in a similar, well, this is better than standard and raises the bar significantly and doesn't have major impacts, and then a second level of this is really good but has significant impact. So it's to give you, like I say, the aim's to give you guidance and tools and the assurance that these kind of, should triple DES be in there, or should we allow SSH at all, or that kind of thing, have been debated by the wider security community quite in depth. And in a transparent way, you can see all of those discussions and judge for yourself as to what's appropriate for your organisation. Thanks for your question.
One more?
I had a question about the tooling, basically. So can you say something about that? So I'm a Nessus user.
Okay.
But I don't really have any, I've never really looked at the professional version of CISCAT, and you mentioned some other tools.
So
are they almost on the same level, or are there certain
advantages,
disadvantages, especially in the concept of automation? That's what I'm really interested
in. So the aim is, CISCAT is there to help as many members as possible and give them a tool without requiring them to go off and buy something else. But it is a non-profits body, and it's a widely cited set of recommendations. So vendor members like Tripwire or Qualys or Dell and so on can certify their products against either some benchmarks, or things like Tripwire are basically the whole lot of benchmarks, and can also give you your reports in the form of a template that's used in CIS RAM to tell you how you're doing against the critical controls and kind of link all of that up. CISCAT is a relatively basic tool compared to something like that, but it doesn't require all of the further integration. Obviously, some other tools will give you some automated remediation straight off the bat, and if you already have Tripwire deployed or you already have some other one, then it's an easy way to extend and use your existing tooling to help you achieve it. But I'm not sure whether Nessus is in there or not off the top of my head, but we can check afterwards.
Great, thank you. So thank you very much.
Okay, thanks
brilliant.
very much, guys. Coffee time.